Welcome to Almost Here, Round the Corner Future Technology podcasts with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Coming to Dallas, Texas, September 14th, 15th, and 16th, 2018, the Blockchain and Future Tech Expo. This is going to be a gigantic conference of over 5,000 people. We're going to be talking about blockchain and its applications. We're going to be talking about quantum computing, cybersecurity, artificial intelligence, and several other future technologies that are poised to and actually changing our lives as we speak. Here's why you should attend. As you may know, early adopters are the ones that investigated and profited from things like the gold rush in the 1800s, from the dot-com boom in the 1990s, from the internet boom in 2005, from the smartphone explosion in 2007, from the real estate boom that ended in 2008, and of course, from the Bitcoin boom that started in 2012. Early adopters act now. They don't wait till later. They go out west first. In their covered wagons, they find the biggest gold nuggets. If you consider yourself an early adopter and you want to find the biggest nuggets, then you owe it to yourself to attend this upcoming conference. Blockchain is going to affect how we control and store our medical data, how we send money around the world, how we bank, and more. But artificial intelligence, quantum computing, and cybersecurity will play a pivotal role in our lives as well. And that's why our next event, September 14th to the 16th at the Dallas Convention Center, is going to have not only 5,000 plus attendees, but will showcase blockchain, AI, cybersecurity, quantum computing, and more. You want to get in on the coming gold rush of future tech and opportunity as an early adopter. Don't be left out. To register, go to bftexpo.com. That's blockchainfuturetechexpo.com. Thank you.
Hello and welcome to Future Tech Podcast. This is Juliet Lamar, and my guest today is Leif Lundbaek, and he is calling as the CEO and co-founder of Xain. Hi, how are you, Leif?
Yeah, hi. Nice to hear about you. Thanks for being here as well.
Of course. Why don't you go ahead and give us an overview about Xain?
Xain essentially is kind of like a very flexible and decentralized access control platform. Also using kind of like a hybrid blockchain solution and using also some kind of machine learning, especially reinforcement learning, also to strengthen the network basically, and also kind of like to have a very dynamic whitelisting, for example, when you're like in a setting of machines. We started this project basically as a research project entirely in Oxford University in 2014, and we kind of like evolved through many different stages into what we are now.
Wonderful. I'm looking over here. So you use AI in a lot of your things. Is that correct?
Essentially, when we started this project, we kind of had the problem that we wanted to build like a completely decentralized network of actually decentralized intelligence solutions. So, if you would, for example, imagine like Google as a very, of course, strong example of being like a very central entity with intelligence solution, of course, we kind of like had the idea at our department also to really decentralize the learning itself. So in order to really gather all the data into one single place, we just have the data where it is and learn from the data where it is, and then share basically the knowledge only instead of like the entire data from all the different objects. So, for example, we had this kind of like robotics case where different robots were learning, for example, how to move in a certain room, and they were just sharing the knowledge with another robot that is like, for example, positioned in a completely different room without like seeing each other. But then, of course, you need to also trust the different robots because they were, of course, not really seeing each other, and they were also not knowing about each other. Of course, like one solution is really like this kind of like centralized solution where like all the different robots have like an identity, and they just share the data into like the central entity, which could be, for example, Google, which could be Facebook, could be whatever. But here we really need to trust each other because we don't even have any central entity, and we just share the knowledge. So one another example could be, for example, picking robots that share the knowledge how to really pick a certain part, and also don't really share all the, for example, private data, but just share like how to really do it. So this is essentially like the idea that we had, and it's called basically decentralized machine learning. At the end, we came up with a platform called the Expandable AI Network, which is Xain. But Xain is a bit more than that, because what we really learned also during the last year, especially when we were focusing on really product implementations based on our platform, that actually what we really need here is access control, because at the end, the user should always be in the central position to decide whether he really allows to share also his knowledge and his data or not. So, and also in order to really achieve this in a very dynamic way, because otherwise you would still have like a central entity to say, okay, this user is allowed to be part of the network and this is not allowed to be part of the network. We also use like this kind of approach of decentralized machine learning in the network itself. So we have like anomaly detection, which is like a machine learning mechanism to say whether someone is acting in a very good way or someone is acting in a bad way. We also have like this kind of like deterministic way of actually deciding who is really trustworthy and who is not trustworthy. And each of these entities is actually taking part in this game and is also learning from himself whether someone is acting trustworthy or not. So this is really what we try to achieve here.
Wonderful. So what kind of companies do you think would benefit most from using this kind of technology?
That was also like kind of like a learning curve. So when we were just like a university project, which we were for quite a few years, we were basically just developing our platform and did not really interact that much with companies. We did some formal verifications for existing systems, for different banks, for companies. We started basically then working together with Mercedes-Benz. But especially during the last year, we, as we had like different proof of concepts, different pilot systems, we learned that mostly really need to focus here on the machines. So our solution is basically like an embedded solution, because we were also like from the start focusing on embedded hardware, really on embedded systems. And we could really achieve this like secure channel between the machines based on this access control network. And so last year we won the first Porsche Innovation Contest against like 120 startups. And this was also like a start of a very fruitful partnership with Porsche, where we actually succeeded also to implement a direct hybrid client system inside of the car on a microcontroller level. And we could basically achieve like a network between different cars. And these cars each have also this kind of like user-centric approach, where the user can decide whether, for example, like an insurance company can use a telematic insurance based on the driving behavior data to say whether he is paying more or less, or he can, for example, like immediately use peer-to-peer car sharing, so he can, for example, rent his car to someone else at a specific time. And you can also use this in offline mode. So currently in existing solutions, you always need to go via a backend, which means essentially that when you're, for example, in a forest and you want to open your car with your mobile phone, then this is not possible. But here in our solution, it's completely possible, and you can execute basically like a method, which could, for example, be open the car or open the trunk, for example, with a postman, or get the driving behavior data for like a telematic insurance or so. You can basically decide over all these kind of like different methods, and it's extremely flexible. So the only thing that you need to do is basically to define this platform once, and then when you build a new application, it's extremely fast. And this is also what the automotive manufacturers kind of really need here, because currently when they build a car, it's already outdated. But actually they always need to think about like what is the user actually wanting in 8 years, for example, because this is development cycles for cars currently. So this is, of course, extremely complex. So what they really need to be is being fast and implementing new applications when the car is actually being produced. So this platform helps them really in being fast of implementing a new solution. One example is here that we integrated like a DHL trunk opening case into the solution, and this took us just half a day to integrate it. And this is, of course, like much faster than what you would do, for example, when building a new app in the Apple App Store, for example. Yeah.
Wow. So you're really taking, I mean, the car is such relatable technology that most people use every day. You could almost fully automate this car to anticipate your needs. Is that something you'd be working towards?
Yes. So essentially, this is really like the car itself is like a full participant in the network. And I mean, also what we basically had as a problem was when we thought about like this kind of like decentralized intelligent systems as our vision, that, I mean, if you use, for example, just a normal blockchain system like Ethereum, they are not as decentralized as you might think of. They have a very strong focus, for example, of server farms being located somewhere in China or so, where, for example, you would replace like a known central entity like Google with unknown, quite oligarchic or almost central entities sitting somewhere in China or wherever, because they, of course, have huge influence over their computing power. And also, of course, in blockchain systems, there is like the approach of proof of stake, and also Ethereum, for example, is turning into like a more like a proof of stake system, and this also leads to a very unequal system at the end, because also the wealth distribution and stake distribution in Ethereum is extremely unequal, and this is not what we really wanted to have as a decentral system. We really had in mind that each machine and each object is really having the exact same stake in the network. So we also created a new consensus mechanism called proof of kernel work, which is extremely energy efficient and also basically making it possible that we actually integrate this client inside the car. And the car is really like a full member. The car is basically mining. I mean, mining not in the terms of Bitcoin mining, but actually verifying its own transactions, and also able to verify transactions of others in the network. So at the end, we have really a decentralized network of cars, and only between these cars, all the transactions are processed, and there is no really interaction needed from the car manufacturer itself, because at the end, it's like a kind of like public permission system, because the user is the one that is really the owner of the car, and he is really the participant in the network using his machine. And so the car manufacturer is basically not really restricting anything, but the user is in control. He is really permissioning the system in a way that he decides whoever is really entering his car, for example, or using the car data.
Wow. Would this also make, if every car had this, could this also make cars safer in preventing and predicting potential accidents or hazards? And could the cars communicate to each other?
Yeah, it's at the end it's a safety function and security function. So this means that currently it's really easy to hack into a car, but here you would basically need to fool the entire network into for really hacking into a car, because the car client is really kind of like the single gateway. Everything that goes in and goes out of the car needs to be verified by the client, and essentially needs to be verified by the network. So, of course, we also allow here offline functionalities, which means that you can execute a method immediately, but it doesn't really prevent anything. So after you have executed a method, like you open the car with your mobile phone in a direct connection, all the connections that you have made is then directly locked with a network and processed with a network. So this is essentially how it works here. And in terms of intelligent functionalities, there is, of course, the opportunity here to share the knowledge. For example, when it comes to autonomous driving, this is in very early stages. However, because also here you could, of course, imagine that a car shares the knowledge, for example, of how it learned to drive. this is essentially quite a nice solution when you imagine, for example, that currently all the autonomous driving functionalities are trained like in very safe functionality in very safe environments, like in the Silicon Valley or I don't know, like in Stuttgart or so in Germany. But essentially, also the cars need to drive in very unregulated environments, like somewhere in India where cattle is walking around the street. This is, of course, not really what the car is essentially learning in the first place. So here we can think about additional intelligent functionalities like learning from different environments and sharing this knowledge instead of like sharing the entire data. Because, of course, when you share all the data into one single place, it's not really privacy friendly, and you basically reveal all the user data that might be there. And this is, of course, not really what you would always want to have. But sharing the knowledge how to drive in a certain area is, of course, extremely privacy friendly.
Excellent. Yeah. So I love that because it's learning, but also you're keeping in mind that security is of the utmost priority.
Yeah.
What is the biggest lesson? What is the biggest lesson that you've learned through working with these technologies? What are some of the things you've learned?
I mean, the biggest lesson I would say is really that at the end, this kind of distributed technology is really an auditing platform. I mean, we all try to achieve like all sorts of different solutions. They might be extremely fancy and so, but you really need to rely also on traditional technologies. Blockchain itself cannot really solve everything from its own. So you always need to think about hybrid systems. You need to think about what is really the benefits that blockchain really brings here and what is also the benefits that traditional technologies bring. I mean, also database technologies have solved many different problems in terms of scalability. And so we need to think about like really hybrid approaches here in order to really make it production ready. Because at the end, we want that this technology is also used in our daily life. But in order to really achieve this, we really need to think basically beyond like the boundaries of just blockchain or just database systems.
Exactly. So where do you see that going? What is your ultimate goal?
So our goal is really to think basically beyond like this pure technology, and so we're currently also experimenting with like more hybrid approaches. I mean, we already have our processor clients, which themselves are quite like a hybrid approach. So they're basically mining clients, but they have like a recursive pyramid data structure, which might sound abstract, but essentially means that it doesn't store everything. So it can process all transactions, but over time the storage density decreases. But it can always match up with like the entire full client. So this is really like a kind of really hybrid approach here, but it has the necessary storage really in order to be implemented inside, for example, a car, which has of course restricted storage here. I mean, and on the other hand, of course, like there's a lot of scalability problems that we need to solve, where we think about like sharding networks, which is also like in this plasma strategy of Ethereum, quite a large portion also that they try to solve. And also we think about hash graphs now. So there's a lot of really hybrid solutions that are taking place here now in the development.
Wonderful. Why are you using just Ethereum and not several different ones? Is that for your company?
Yeah, I mean, we are quite agnostic towards that. I mean, we use like Xain for the machine network, and we currently basically see us as kind of like the machine network or the machine Ethereum, basically. But I mean, we're actually from the code quite far away from like actual Ethereum. We just integrate EVM. The EVM, which is like the Ethereum virtual machine, makes it possible to basically for corporations to write smart contracts in Solidity, which many corporations already know how to do, which is quite nice for them. So we basically offer them that service. But of course, it has like certain problems as well. Well, At the end, I think Ethereum has like the most active community. So a lot of good developments are coming really from this kind of space. But we also look actively for like different solutions and try to combine different solutions. And well, for example, when you have like when you want to have a protocol between these kind of machines for payments and so, we can interact or integrate kind of like all sorts of different solutions. This can be Ethereum itself, can be Stellar, can be any kind of protocol, and we also do that. So we don't really focus on the payment part. We just really focus on the machine and access control part and the security stack. And then, of course, we need all sorts of different protocols for different purposes. So at the end, I think it's really a field where we need like an entire ecosystem of different purpose blockchains or domain-specific blockchains.
Absolutely. So where can people find out more about your company?
So the best way to connect is currently really to write to us. We have a Twitter account. We have, of course, on our website. We published a yellow paper where we have basically all the mathematical details published. We have quite an active Medium account where we also publish how really our system functions here in the space. We are also in the process of publishing our code to go open source. This is like not completely trivial for us because of course we work together with like different very large companies here. So it's not like an immediate step, but it will happen during the next kind of like 10 weeks. We will basically, we kind of like consider us to be like in between like the corporations and the community. We of course like not a complete community project, but we basically see us as like an integration part.
Absolutely. Well, Leif, thank you so much for joining me today. It has been such a pleasure talking with you, and hopefully your technology will be everywhere quite soon. I like this idea of never having to lock my keys in the car again. My phone will just save the day.
Yeah, exactly. Thank you very much also for being part. Thanks.
Of course. That was Leif Lundbaek with Xain. Thank you so much.
Thank you also.
This has been Juliet Lamar with Future Tech Podcast. Thanks for tuning in.
Coming to Dallas, Texas, September 14th, 15th, and 16th, 2018, the Blockchain and Future Tech Expo. This is going to be a gigantic conference of over 5,000 people. We're going to be talking about blockchain and its applications. We're going to be talking about quantum computing, cybersecurity, artificial intelligence, and several other future technologies that are poised to and actually changing our lives as we speak. Here's why you should attend. As you may know, early adopters are the ones that investigated and profited from things like the gold rush in the 1800s, from the dot-com boom in the 1990s, from the internet boom in 2005, from the smartphone explosion in 2007, from the real estate boom that ended in 2008, and of course, from the Bitcoin boom that started in 2012. Early adopters act now. They don't wait till later. They go out west first. In their covered wagons, they find the biggest gold nuggets. If you consider yourself an early adopter and you want to find the biggest nuggets, then you owe it to yourself to attend this upcoming conference. Blockchain is going to affect how we control and store our medical data, how we send money around the world, how we bank, and more. But artificial intelligence, quantum computing, and cybersecurity will play a pivotal role in our lives as well. And that's why our next event, September 14th to the 16th at the Dallas Convention Center, is going to have not only 5,000 plus attendees, but will showcase blockchain, AI, cybersecurity, quantum computing, and more. You want to get in on the coming gold rush of future tech and opportunity as an early adopter. Don't be left out. To register, go to bftexpo.com. That's blockchainfuturetechexpo.com. Thank you. You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.